Welcome to our second AI building video. This is a follow-up to our quite popular how not to build with AI. And in this video, we're actually going to cover how to build with AI, common tools and common concepts. As a reminder, in the first video, we discussed that when building with AI, the number one mistake that is made is trying to figure out what AI to use, how to use it, etc. And usually it turns into paralysis by analysis. So the right approach is actually not to think about AI, but first formalize the process, the inputs process, the output, meaning what do you want to take? So we used the example of, let's say, emails or PDF files coming in. How do you want to process them, sort them, etc. And what is desired output, for example, report, etc. Interestingly enough, following this approach, we received a flood of messages, text messages, DMs from clients, etc., where they were all actually getting fired up and how to approach it. However, now most of them realize that they're hitting a wall, meaning they don't know how to actually put this into action, and that is the purpose of this video. As we're beginning to discuss layers and tools, I do want to mention that the tools brought up in the video, they're not the only options, they're quite popular options. I do also make an effort to stay within open source domain, meaning most of those tools you can run locally free of charge, which minimizes the budget for the AI implementation. Now, let's begin with layer one. So the most obvious task that needs to be done when data comes in, what do you do with it, right? How do you traffic it through the system? Let's put it this way, right? There are many solutions. You probably heard of N8N. There is sort of like an automation solution. Once you start approaching things at scale with AI, extremely common solution is Apache Airflow, right? There's also Prefect that is used for intersystem data, but in our case, if you think of a traffic controller, sort of like a traffic cop, right, that decides what to do with data that comes in, would be the Apache Airflow. Okay. So now if we think of the Apache Airflow or the orchestration layer as a traffic controller, right? So that system works more on, conceptually on if-then, right, flows. So it not necessarily makes evaluations and decisions, so to speak, right? If you have multiple models in your system, there needs to be a layer above it that makes a decision which model to use. What do we mean by that? For example, as a simple example, if you want to read the PDF file or read the email or calculate something, or in the language model that can actually, let's say, legal language model that can read the document, right? You can have multiple models in the system, and usually if you create a more advanced stack, you will have multiple models, but there needs to be a layer above that decides, okay, based on the incoming traffic, right? Let's say what's coming from the orchestration layer. What model should I be using? And this LangChain is actually a very common solution that is used for that. By the way, it's also open source and it's quite powerful. Has a big community, documentation support, etc. But this would be the layer that goes on top of your models. So now a very common solution for, let's just call it for now, framework for storing the models, right? Just keeping them, let's say, put them like in one, house, called PyTorch, right? And the Hugging Face, that's the, I mean, at this point, I don't know what it is. Like, it's not even a community. It's like it's ecosystem of its own, and they have pre-trained models that you can download. It's for free. You can train them yourself, etc. All of everything I'm describing right now, the hosting of the models, training them, adjusting them, you need to keep it all into one like framework. And PyTorch is extremely popular solution for that. It both allows you to host the models, to train them, to fine tune them. That's what training is. Build them from train them from scratch, etc. And that's actually where the models are going to exist, right? So to follow through the steps, we have layer one, orchestration. This is, if then, let's put it this way. It directs the traffic, then it directs the traffic to LangChain, and the LangChain decides basically which model to use within the model layer. So in general terms, the data and context layer is where let's take an example. Let's say using a pre-trained model for your customers, okay, and you evaluating your customers' data based using that model. The model needs to understand based on the customer what is specific to the customer. So basically, you need to store that context somewhere, right? And you can use for the databases. This is a much deeper topic about the vector databases, etc. But that's where you would need some sort of a storage solution, let's put it this way, where you're storing specific data for a model to be able to read and understand. Again, a simple example is, let's say you have one model that is trained to read certain type of a document, but you have 20 customers. So specific data to those customers will be in a database or whatever solution you're using. Model will refer to it and use it for the context, how to solve the issue for that customer using the model. So very similar to the feedback layer, monitoring layer is essential because you need to be able to trust your data and your system. And if something goes wrong, performance-wise, errors, if the quality drifts, you need to see that right away so you can correct it. And it will happen a lot as you actually building out the system. The number of errors will be reduced as time goes by, but it's essential for you to see in the beginning what is happening. So the solution like MLflow or Grafana, they're wonderful, highly popular solutions. There are more, but this layer must be planned for. So to recap quickly, we need orchestration layer, which is basically a traffic controller. We need a layer to decide which of the models to use to solve a problem. We need the third layer, which is the model layer. That's the place where the models basically exist, where they're stored, where they're trained, fine-tuned, etc. Okay. We need the fourth layer, which is data or context layer. And this is where we're storing information specific to, let's say customers, etc. And in order to have quality and for the system to be reliable, we need feedback layer and monitoring layer. So on this image, if you can see basically the last two layers are layers for the improvement. The top layers are actually what runs the system. So in the next videos, we will, discuss more in details each layer because each layer truly deserves its own video. But now you have a bit of better idea on how it works. Thank you.